Hello, everyone. Good morning. My name is Maggie Lage, and it's good to have you here. Welcome to the R&D session powered by EDP New. For those of you who are not so familiar with EDP New is the research center of the EDP Group, and we work with European R&D projects, looking at innovative solutions for decarbonization, smartification, and flexibility of the energy sector. We have been organizing these R&D sessions since 2020, and the aim of our session is to get together experts to discuss several topics regarding the future of energy, the challenges we are facing, and the solutions that we are already putting into practice to change the energy sector.
Good morning, everyone. Please note that these webinars are recorded and the previous sessions are available on our website. You just need to read the QR code on the next slide, and you will be able to watch them. Also, this session will be available in our website and YouTube channels in a couple of days. For today's webinar, we want to encourage you to use our Q&A chat to ask your questions to our guest speakers. And at the end of the session, we will have these Q&A moments where the speakers will be able to answer you. With no further delays, we welcome you to this event and wish you all a great session. But let me first introducing you our moderator, Daniel Albuquerque. Daniel is a senior project manager at EDPNU. He holds a PhD in sustainable energy systems and a master's in energy engineering from the University of Lisbon. And with over 7 years of experience in building energy consultancy, Daniel worked in the design and thermal performance of iconic buildings in Lisbon, including the new PLMJ and PMJ office building and the refurbishment of the Gulbenkian Centro de Arte Moderna. In his journey of 2.5 years at EDPNU, Daniel has primarily focused on EU-funded and consultancy projects related to smart buildings, smart cities, and renewable technologies. Currently, Daniel is leading Talos project, a 3-year EU-funded project aims to revolutionize the operation and maintenance tasks of PV plants through the integration of autonomous robotics and AI. So, Daniel, now the floor is yours, and thank you so much.
Thank you, Inez, and thank you, Maggie, for the kind words. Thank you also for organizing these marvelous R&D sessions. So it's also a pleasure to be the moderator of today's session, especially on such an important topic of PV and the way that PV the role that PV can have, especially in the decarbonization of the energy sector. So thank you for the invitation. So let me give you a little bit more details about the agenda of today's session. So we'll have 3 guest speakers. Each one will have more or less 10 minutes to present, and then we'll have a Q&A section where your questions will be answered. So again, as my colleagues already told you, please use the Teams chat to pose your questions to our speakers. So regarding our first speaker, we'll talk about a little bit the duality of agriculture and also the duality of agriculture with photovoltaics, with the presentation entitled Unlocking the Power of Agrivoltaics and Tap Potential in Solar Agriculture Integration. Then our second speaker will show how the offshore solar is taking shape and rapidly gaining some momentum and scale with the presentation on offshore solar technology as a breakthrough for large-scale solar projects. And then our third guest speaker will give us a glimpse into China's future with an overview of emerging technologies and innovations in the PV sector, with its presentation Getting Ready to 3060. So without further ado, I will now introduce today's first guest speaker. So Cláudia Fernandes is an R&D engineer at EDPNU. She works at the Renewables Energy Sources Unit with a focus on PV technologies. She holds a master's degree in aerospace engineering with previous experience in UAV technology design and aerodynamic optimization, deep sea ROV design, and also quality engineering. Whilst on ADP, she participated in energy community projects and worked on the electrification on energy-intensive industry sectors. She's currently working on projects regarding the automation of O&M tasks on different PV pilots and the recycling, circularity, and sustainability of PV modules. She's also coordinating the Ogen AgriPV project, which aims to study and analyze this duality of photovoltaics with agriculture, including an ideation for an AgriPV pilot in the southern region of Portugal. So, Cláudia, please take the stage.
Thank you so much, Daniel, for the introduction. And so today here I bring you a little bit more on the themes of agrivoltaics. And this presentation will be also focused on the study that is been currently ongoing, which is called Ocean AgriPV, sponsored by EDP Produção. And this project is being developed not only by EDP but also in collaboration with Universidade de Évora. And for that, I want to bring you here a little bit of the context. So basically the main frame in which this project started was due to the potential of agrivoltaics to exceed the entirety of Europe's solar PV goals by 2030 through only the development of 1% of utilized agricultural land. And of course, some of the main insights that we already obtained was that not only is there a panoply of different technical solutions already available for us to implement, but there are also various pilots that already showcase the viability of these benefits applied to different cultures. And also various business models can also be built in order to center the farmers and the farmers associations in order to maximize the yields and also potentiate the dual usage of lands. But there's also a big lack on the regulatory framework, especially on an European level. And first of all, I want to give a quick introduction on the definition of what it is, the agrivoltaics, which can be defined by the simultaneous use of land for both the PV power generation and also the agricultural production. And this definition can be divided into two different segments. So basically the closed one, which can represent, for example, greenhouses and even other support infrastructures. But you can also have an open agrivoltaics based on interspace, so vertical solutions, overhead solutions, but also panels built within the fences. And this can be seen in these images here, where the first ones, especially A, is a prime example of an overhead structure and solution. And we have here B and C, interspace solutions with the coupling of a tracking system, for example, in the example B. But you also have different ones, such as, for example, arc-shaped modules that can move freely along this axis, and also even completely mobile photovoltaic arrays. In terms of pilots, we can see here that there has been already quite a few that are being implemented, and they've been ongoing for a couple of years. Being Germany, France, and the Netherlands, the main countries leading these developments, and they showed the viability not only with various different technologies, either overhead or interspace, but also with different cultures. And we hope to have in the OGEN study a proposal to make a pilot, especially in the region of Vidigueira, in a few months. And in terms of the pilots and the technology that is being installed, we know that in 2021, 14 gigawatt peaks of capacity were installed amongst the world. And you can see how it is distributed currently, and also interviews with many EPCs, R&D centers, and also AgriPV tech developers provided us the insights and the know-how on what the main challenges were, and also the main improvements that happened in some of these pilots. And we can have basically a reduction in water consumption. We can have also different expectations for sugar levels in fruits, a reduction of pesticide use, improvement of the overall crop health, but there was also some cases where regions that are very different, have different climates that Iberia, that presented a slight reduction in the crop yields. But also there is the need, of course, to streamline the legislation amongst the countries, and this issue can be seen overall that, in fact, the European landscape does lack harmonization in terms of regulation on AgriPV. Some countries, such as Germany, France, and Italy, already have a clear definition of what they are and present various different different factors that can decide on whether a land can be applied or not for agrivoltaics, but it is not yet clear. There's no clear trend amongst Europe. And since in Portugal we still lack a clear definition of agrivoltaics, we want to explore this a little bit further, and we also aim to present a case study that is still under development. And for that, several workshops are being held with national stakeholders, that includes farmers, environmental agencies, and public entities, to further discuss not only the legislative issues and framework, but also sustainability issues and the needs and pains of the local farmers in order to potentiate and develop this solution to be catered towards them. And finally, what we have seen, I think, for the next steps of this project, it is needed to, the study of both the policy and regulation needs refinement within Europe itself, and also a market characterization of both Europe and Portugal is a clear necessity, as well as the developments of business models that can be catered towards farmers and also involving the community in itself. And for that, we can draw four main guidelines for now. That first of all, an AgriPV technology is not a one-size-fits-all solution, and we do have a panoply of technologies that can be well suited for certain crops and certain terrains, depending on the conditions. We can also see that the AgriPV applied to existing farms can pose additional challenges in the terms that some farmers may lack the adequate equipment and the machineries may or may not be adapted, so this can increase the level of complexity of a project. But also we do have a lack of regulatory and legislative frameworks on AgriPV in Europe, and it's something to look for, to take into consideration, but also further analyses are still in progress. The project is still ongoing, so we need to evaluate and wait for the final results to have a better understanding of the entire view of agrivoltaic, especially applied to Portugal. Thank you so much for your time.
Thank you so much, Cláudia, to have this glimpse on agrivoltaics and the opportunities that also agrivoltaics can take to this energy sector. So thank you so much. So I'll now move I'll now present our next speaker. So give me a second to share my screen again. Okay, I think now everyone can see it. So our second speaker is John Meit. He's the head of business development, sales and project development at Oceans of Energy. He has been active in the field of offshore solar since 2017, with previous experience in venture capital. At Oceans of Energy, Johnny Meit has contributed to successful development of the company, resulting in 8 years of offshore solar technology development, 4 years of operations in offshore conditions, and 2 technology certifications, and the first commercial contract of an offshore solar farm in the world. Johnny is the project manager of a EU-funded project, the EU Scores, in which, amongst others, Oceans of Energy and EDP Renewables are collaborating on the development of offshore solar farm as a way to increase the value of offshore wind farms and on the development of the North Sea 3 demonstrator at the port of Ostend. So, Johnny, the floor is yours.
Thank you, Daniel. So, good morning all. Let me see if the presentation works. Yeah, so good morning. My name is Johnny Meit. Thanks for the introduction, Daniel, and also thank you for the invitation at the EDP. It's really exciting to be part of our collaboration that we have so far, and also exciting journey that we are exploring together. What you see here in this image is our North Sea 2 offshore solar farm that has been operational for 4 years at the site 12 kilometers offshore in the Dutch North Sea. And you see here in the picture, you also see our founder and CEO Allard van Hoeken, together with the King of the Netherlands, Willem-Alexander. So we had a royal visit in which they visited our offshore solar farm back 1 year ago. What we do at Oceans of Energy is we first of all we build our offshore solar farm technology. So in the upper image you see our fabrication facility that's located in the Netherlands, where we build platforms where we install PV modules upon. Then we bring these platforms to ports, and we build up offshore solar farm arrays in port. So the image that you see here, that is a recent establishment that we have concluded, which is the import assembly of the first part of the North Sea 3 offshore solar farm, which is part of the EU SCORES innovation program funded by Horizon 2020, in which Oceans of Energy and EDP are collaborating. Then, in addition, we install these offshore solar farms by means of towing them to open sea and installing them with the mooring and anchoring system offshore, from where they can be operated, which we also do at Oceans of Energy. Why do we do this? Well, first of all, the problem that we see with large-scale renewables is space. So renewable energy requires a tremendous amount of space in order to establish and implement all of the renewable energy that we need. Our current amount of renewable energies, in terms of not only electricity, but also the final energy consumption that also includes heat and transport, is still rather limited. In order to really scale that up, we require to develop large-scale projects. And that is currently becoming more challenging in densely populated coastal regions. So where we see that it becomes more difficult to develop renewable energy projects on land, we look for the solution, and we find this at sea. So 70% of the world is North Sea, is ocean, and 70% of this is actually available for also the development of our renewables. We particularly aim for the regions that are currently being purposed for offshore wind energy. In between the turbines, we see a lot of space, and by adding offshore solar in between this space, we can accelerate the energy output of the space by a factor 5. In addition, the energy output also becomes more complementary. This means that just with very small amounts of sea space, you can achieve very high amounts of renewable energies. What we showcase here is studies that we have conducted, in which we envisioned a typical offshore wind farm in the Netherlands. They are typically 750 megawatts. And the typical space that such an offshore wind farm conducts is about 125 square kilometers. By adding in between the 60 wind turbines that we find here, 5 arrays of offshore solar farms, we can double the amount of installed capacity. And when you double this, we actually see that it results in a benevolent energy pattern. So whereas wind energy is very high in winter and in autumn, the solar energy actually generates electricity mostly during spring and summer, and therefore contributes to a much more stable energy profile that results actually in a better performance of the wind farm in terms of more balanced revenues, but also a better use and a better utilization of all of the offshore infrastructure. In addition, we focus with our research a lot on the environmental interactions of offshore solar. So what we see actually is that by assessing the environmental interactions in innovation projects such as EU scores, we can establish already predictions on the environmental impacts of large-scale offshore solar. So far, based on modeling research, this looks very positive in the sense of that we see that our floating farms result actually in floating reefs, where actually a fish is attracted to and where life is spanning. So that means that we have below our platforms, we have mussels, we have algae, and those actually become fish breeding zones that result actually in attracting more life. In addition, we also see like that the impacts of light attenuation of shading are negligible, so these have no impacts. What we expect is actually that based on research that if you want for establishing an impact on the light attenuation on primary production, so that is the algae that require photosynthesis, it is required to cover more than 10% of a sea basin. That means tens of thousands of square kilometers of offshore solar, which is completely not necessary and therefore also not realistic to establish that. Within the boundaries that we see within the offshore wind farms, there will be zero environmental impacts from shading and covering the sea space. This therefore results in actually that the offshore solar market is extremely large. So everywhere where there is offshore wind industry, you can add offshore solar. In addition, many islands in the world have difficulties to develop renewable energies on land, but they are all surrounded by sea space. Those are also promising locations for offshore solar. Furthermore, we have several coastal megacities across the world which require a gigantic amount of renewable energies, and for this also offshore solar can become a very key solution. And then there are also market niches such as offshore oil and gas. In practice, we see that about 40% of the world population lives near the coast. It also means that about 40% of the energy use worldwide is required at coastal regions. And as these are also the most densely located places, these are the most challenging to build large-scale renewables. In terms of offshore solar, we see already quite some market developments, particularly in the Netherlands. So based on an innovation program in offshore wind farm concession tenders, we have seen that already in 2020, the first 0.5 megawatt offshore solar farm was tendered. Oceans of Energy will build this one in 2026, in 2025 at the Crosswind project of Shell and Eneco. In the next offshore wind farm tender, the Netherlands requested a 5 megawatt offshore solar farm, and in the tender that has recently been submitted, a 50 megawatt offshore solar tender was included as part of the award-winning criteria for the offshore wind farm concession. We expect that this further progresses and that possibly with steps of 10, again, in each tender, the amount of offshore solar renewables will be further increased, and that by such we can go towards very large-scale offshore solar in a very short term. In addition, we also see other European countries following, including Belgium, Italy, Greece, and Malta. So in Italy, there are already talks for first feed-in tariffs, and in Greece, regulations are in place. In Malta, we have seen a market consultation by the government, and in Belgium, there are also dedicated talks towards a tender for offshore solar. The Oceans of Energy offshore solar farm system is then the only certified and offshore proven solution with our 4 years of operations. And we see this as a typical solution to develop a standard format of 200 megawatts that includes 1 square kilometer. Our technology consists of modular prefab floating platform units on which we install solar PV modules. And we develop these platforms in such a way that they use the sea surface to rest on. So it acts a little bit like a water lily. This results in that we have very slim, flat, and low hydrodynamic loads. So we have no wind impacts because our PV modules are without an air gap located on our platforms. Also during storms, when we have very heavy winds and very heavy storms and waves of more than 10 meters that we encountered, and these waves in the North Sea tend to be very steep, we see actually that our system follows the waves in such a way that the impacts from the environment are minimized. In addition, our focus is very much on standardizing and modularity and scalability. So by doing everything in a prefab standard unit form, we can actually expand and mass fabricate our technology to go towards very large projects that tend to result in large economies of scale. And finally, we also emphasize a lot on the monitoring of our system, and with an asset integrity monitoring system that we have included, we can provide data management that can also ensure the farm lifetime. The pathway that we have taken started back in 2016 when our company was founded. We immediately took a learning by doing approach and started concept testing already in 2017 and used our testing possibilities to further improve and further expand our system throughout our developments. This year, in 2024, we aim to establish the North Sea 3 project, for which you saw already the picture of the import assembly at the port of Oostende, 2 kilometers offshore with a grid connection, which hopefully becomes possible before the end of this year or might result next year. In addition, in 2025, we have our first commercial implementation in the Hollandse Kust Noord project, which is an operational offshore wind farm operated by Shell and Eneco, where we integrate a 0.5 megawatt offshore solar farm. Our next step is to include a 20 megawatt offshore solar scale system. And from there on, we envision that we can develop 200 megawatt standard offshore solar farm sizes already by 2028. This should then lead to about 2 gigawatts of installed capacity by 2030. As mentioned, we have certifications in place for our technology that have been based mostly upon the experience during testing for extreme conditions at the North Sea and also our operational experience. These are the only certifications for offshore solar technology that include operational experience in offshore conditions, as Oceans of Energy is so far the only organization that has established the system for multiple years in an offshore site in the North Sea. Our next outlook is part also of like the standard format of the 200 megawatts. At Oceans of Energy, we see this to become the industry standard. What we will aim to establish is a square kilometer floating farm, which we can use as a blueprint and as a standard form that we can install in between 4 offshore wind turbines worldwide. As there will be thousands of offshore wind turbines in the world by 2030, this also means that there are thousands of such offshore solar farm formats possible for implementation. And for this at Oceans of Energy, we are currently standardizing our technology towards like this large-scale technology. For that, we also collaborate together with 15 partners in a European project called Bamboo. Thank you for giving this presentation. I believe we have more room for questions after the third presentation, and I'm really looking forward to your feedback and questions. Thank you.
Yeah, for sure. Thank you, Johnny. Thanks for the nice presentation and also for showing us how this offshore wind and solar can be somehow complementary. So now I will just introduce our third speaker. Let me just share the screen again. Let me just introduce you first with me sharing the screen, and then you can share to present everything that you have to present for today. So Yibing Wang is a senior electrical engineer and a project manager from New Energy Department of Shanghai Investigation, Design and Research Institute. He has more than 10 years experience in the new energy industry, focusing on electrical part of PV power generation systems, as well as onshore and offshore wind. In addition, he is always keeping himself updated to the latest development trends of PV technologies and has a good understanding of China's PV sector. So Yibing, please take the floor. Now you can share the screen.
Okay. Oh, thank you for the opportunity to have me to present here. Today I would like to talk about what China is doing in PV sector. The presentation has 4 parts. First, I will explain what 3016 is. Then we will have an overview of China's PV sector. The third part focuses on the emerging technologies, and the fourth part, the challenges we are facing too, and what the solutions are. So, in the title, 3016 is the long-term target of energy transition of China. On September 22nd, 2020, China's President Mr. Xi Jinping presented at the General Debate of the United Nations, and he declared that China aimed to have carbon dioxide emission peak before 2030 and achieve carbon neutrality before 2060. So that is the origin of 3060 target. So the speech is like a milestone which indicates the beginning of the much larger scale action of energy transition for the next 40 years for China. So let's have an overview of China's PV sector. We can see from this picture, China had the largest annual installed capacity since 2013 among the world, and the capacity has increased tremendously since the target was set. From the year 2021 to 2023, the annual installed capacity is 55 gigawatt, 87 gigawatt, and 217 gigawatt. And 217 accounted for almost half of the global capacity last year. And by the end of last year, China has a total PV capacity of 610 gigawatt. So to support this rapid growth, it is required to have innovations in all aspects of PV power system. First, PV module. We have several technologies in the market. And first is PERC and TOPCon. They accounted for about 95% of the market in China last year. It is estimated that TOPCon will occupy almost 70% of the market share in the next 2 or 3 years. And also, we have HJT and IBC. They have advantages like higher bifacial gain, high current, and good performance in low light scenarios, but they still need to be more cost competitive. And then perovskite is a research hotspot. It has already attracted a huge amount of venture capital. So the theoretical efficiency of all perovskite tandem module exceeds 40%. And according to a paper published in February this year, a team from Sichuan University achieved a maximum efficiency of 24.5% in laboratory. And as in real production, Chinese company Microquanta Semiconductor has a product with the maximum peak power of 130 watts, and the efficiency is 16.4%. Second, the inverter. Since the inverters are smarter than before, now some manufacturers call it controller. In China, string inverters has a 70% market share in scaling PV stations. We choose string inverter usually for its higher efficiency, especially in the areas where irradiation is not uniformly distributed. To pursue a higher efficiency of the system, the industry now is working on larger output power with the 2 kV DC system, means to raise the maximum input voltage to 2 kV. Then we can have bigger string size and also reduce DC line losses. And for centralized inverter, the appealing feature is its low cost, while we want to make it relatively more flexible. So Chinese manufacturer Sungrow has launched a 1+X centralized inverter. It features a 1.1 megawatt single unit as the minimum, and it can be expanded to the maximum capacity of 8.8 megawatt by combining 8 units together. And the industry is also exploring a mid-voltage inverter, which directly converts 1.5 kV DC to 35 kV AC. It is a solid-state transformer, also known as a power electronic transformer. It is grid supportive and it has a small footprint with high efficiency. These are the innovations of main equipment of PV power system. The innovations of equipment are step by step, sometimes even foreseeable. So I think it is not enough to accelerate the development of PV sector only with innovative equipment. We need scheme innovation as well. Before we talk about the innovative scheme, let's see what challenges China's PV sector is facing too. We have 3 challenges now. First, there's not enough land which is proper for PV stations, or land is sufficient but far from the load center. Second, planning and the construction of grid infrastructure on substations and transmission lines is far behind the demand of PV stations. And third, large-scale new energy power station grows rapidly all around the country and makes it difficult on make the load regulation, the load management difficult. So now China has found a solution, an innovative scheme called New Energy Large Base. It means to build large-scale wind and PV stations in deserts, sandy, and rocky areas. And it also means to plan and construct new energy stations, thermal power plant, battery storage, and export lines simultaneously. In northwest part of China, there's a large area of land which is not suitable for human to live on, but could be the solution for the insufficient land challenge. But electricity demand is very low in those areas, so it has to be transmitted to areas with high population density, usually several thousand kilometers away. The scale of the power supply should be matched perfectly with the load side, and the thermal power plant and battery storage can keep the output stable. So the large base system is relatively independent, and only a little electricity exchanges between the system and the existing grid. And thus, we are able to minimize the demand of grid infrastructure. For example, the export lines are very simple, point to point, and the extension of substations is not required, except for those near the load center. Currently, there are several new energy large bases under planning and construction. Let me give you an example of what is included in a typical new energy large base. 8.5 gigawatt PV, 4 gigawatt of wind, 4 gigawatt of thermal, 4 gigawatt hours of battery storage, and a 2,000 kilometers transmission line with a voltage of DC 800 kV. And we are also exploring more solutions for land challenge, for example, offshore and nearshore PV stations. To build PV stations inside the offshore wind farms is a new concept. Less permission processes are required since some of them are already finished when developing the wind farm. And PV and the wind can share transformers and export lines. For floating PV stations, the mooring may be fixed on the foundation of turbines. And to build PV stations near shore is also a good solution. The foundation is fixed and the cost is relatively low. And we use flexible bracket in mountain region. The flexible bracket has less piles and it can cross the gap of the gully on the mountain to raise the utilization rate of land. Okay, that's my presentation. Thank you.
So much. Thank you so much, Yibing. Now I think we can enter into the Q&A session. So I will go a little bit quick through the first questions. So Cesar Martins has a question to Cláudia. So for AgriPV, how are you planning to mitigate soiling, and how are you going to do the cleaning cycle?
So it's a great question. Right now, since agrivoltaics is a new thematic, O&M is not yet very well discussed still within these projects. We know that there's been some research done, especially in Fraunhofer, in this regard, but we also have a project here at EDP which is called the Talos project, which also is focused on the automation of O&M tasks applied to various solar park scenarios, and it includes, in fact, an AgriPV site, so we are evaluating it. And also in Oxygen AgriPV, it is being currently studied. And what we want to do is integrate the farmers in the solutions, because they will be the ones that will be daily in the farm, so right near the structures. And we want to equip them with the necessary knowledge on how to approach these tasks and how to maintain them if possible. So it's something that we are looking at.
Yeah, maybe just to add a little bit more to your answer regarding the soiling, specifically to answer Cesar's question. I think it will depend a lot on the type of culture that we'll have. So it depends a lot on the site, and with that we are trying to develop some new solutions to get all those panels cleaned, because especially for overhead systems, yeah, there is quite of a barrier, a physical one, to get those panels really well cleaned, and with the frequency that we should have, right, in order not to have a big drop in the performance of the PV system.
Exactly, and also the climate also takes a lot into consideration, depending on where the pallet is located.
Yeah, for sure. Another question from Rui Silvério. also to Cláudia. So good morning. Regarding the Vidigueira project, which is the main schedule steps?
The Ocean AgriPV project is working on this case study in Vidigueira. It is still under development, so we do not have a schedule yet, but we want to propose by the end of the study that all the results will be made public, and we will try to make a proposal. We will make a proposal with different technologies for the sites, and also with a small plan with a short time, with a timeline. And that one is still not set in stone. We are discussing it internally and also with the community, with these workshops. And as soon as we gather all these inputs, we will be able to provide a better overview on the sites and also the capacity, the layouts, and even the crops that will be chosen alongside with Universidade de Évora with their agronomy expertise. So.
Okay, thanks. I think I have a third one for you, Cláudia, from João Mateus. Are there any restrictions on the types of crops that can be grown under photovoltaic panels?
So from what I've seen, all the, especially the overhead solutions allow for every type of crop to be grown underneath it, of course, with the right amount of height. But the main constraints here for the structures are not the crops itself, but the machinery that the crops require for their maintenance. Because the machinery does have very big requirements, because most of them, some of them actually go over the crops itself, and it is not possible to build structures and the foundations for said structures to be able to withstand the wind loads and also have the right dimensions to let through to be able to let through the machineries. But regarding the crops, every type of crops can be applied for this system.
Okay, thanks, Cláudia. I think now I'll have a question for Johnny from Samuel Matias. Considering the harsh environment of offshore PV, what are the expected lifespan of these installations compared to the onshore ones? Do you have an idea on this? Because I mean, I don't know if it's also related, but I mean, salt water can have a very bad effect on metals, so it's quite corrosive. So how are you studying it, and how can you try to increase this lifespan and not be so much affected by these effects of salt water?
Yes, thank you for the question. So in general, at the Oceans of Energy, we face many unknowns related to whether we could make offshore solar work in the offshore setting. But we also encountered certain knowns. One of the big knowns is the environmental conditions, and the salt and the materials that we use all have already been used in offshore industries for a very long time. So based on that knowledge, we could actually assess this into our hydrodynamic models, into our testing programs at laboratories, etc., and include this also in our testing experience and setups. And based on that, we can further improve our system. Our target for our lifetime is 25 years, because we consider this as a good target for renewable energy assets. And now it is our challenge to implement our technology in such a way that with these known conditions offshore, that we can operate our system for 25 years. And so far, we have been doing this very successfully, 4 years of offshore operations. We did encounter certain things that we expected would not happen, but we also actually have been able to solve and address all of these challenges. So one of the examples was we wanted to actually have different tilt angles to assess, like, how can we best establish that we have runoff of salt from our PV modules, because the salt could corrode the glass of the PV modules. There we did several setups, and one of them actually resulted in a huge amount of biofouling on the glass, Others resulted in extreme wave load impacts. And based on that, we had to reiterate our system and the mounting setup in several ways with assessing what is the perfect angle for the system. And with that, we actually, by trial and error, we have implemented this in a way that we have now a successful system.
Okay, perfect. Thank you. A question from Cesar Martins, also to Johnny. Won't this kind of large area floating PV structures cause the birds to stay there and then cause problems with panels getting dirty? How did it go on the pilot? Were there any birds there? What is your experience with birds in general in offshore PV?
Yeah, so we have currently operated our system in 2 sites. One was very close to shore and one was 12 kilometers offshore. We expect that the offshore wind farms where we will be installing our offshore solar farm will be about 20 to 50 kilometers offshore regularly. And we encountered actually that the larger our farm became, the less birds we actually encountered on our system, especially also if we were further offshore where we had more regular waves. If you have the waves, the system moves, and that actually was not attractive for the birds. Then we did see 2 peaks during a year in which a certain group of birds set foot on our platforms. And during those periods, we encountered more frequent bird visits, and then we checked what can we do to resolve this. We tried, for example, making paintings of eyes on so bird eyes. We read somewhere that could possibly help. It helped a bit, but actually what we found out what was best suitable was that during these periods of high frequent visits that we could have, for example, sound mitigation methods that actually signal birds to leave our platforms. So in general, we expect that the larger the system becomes, the more waves we have, so more being more offshore, we have less birds. And that during the visits of these birds that we also have mitigation measures to prevent it from soiling. So hopefully we will actually be much better off than what we see inshore, where there's quite a big problem with bird droppings.
Yeah, thanks. Perfect. Makes sense. Another question from Antonio Vidigal, also to you, Johnny. Are there problems with the shading of wind towers?
No, we believe not. So the wind towers are gigantic. So they are so large that in order to have like that one wind turbine doesn't capture the wind of the second wind turbine, they are extremely far distant from each other. Otherwise, you have efficiency losses per wind turbine. So because they are now 1.5 and in near future possibly 2.5 kilometers away from each other, also the distance to the offshore solar farm will always remain very large, and therefore there will not be an impact from shading effects from the turbine blades.
Okay, not even on the PV panels.
No.
Okay. Okay. Another question from Antonio Vidigal, but now to Yibing. Yibing, is it possible to share a string inverter with a battery and provide ancillary services?
I will check after meeting, maybe.
Okay. Yeah, this was a very technical and very concise question. Andre Luizinho, also a question to you. With more frequent negative prices on dairy energy market, how do we know that photovoltaic solar investments, both onshore and offshore, is economically viable?
In China, it is not a completely open market of electricity. So developers usually sign a protocol with the grid, just like PPA, but the price is not very low. So in China, this is not a problem now.
Not a problem.
Maybe in the future years, the market is more and more open. The problem will be a problem.
Okay. Okay. Another question from João Maciel. also to you. Can you elaborate on this new energy large base? Are there any projects in place already? And what's the status and some more details of concrete projects, if you can share with us?
In China's Mongolia, Xinjiang, and other provinces, a number of large bases projects have already begun to construct. Some of them are under planning, and the project is very huge, so the time span will be long. I think we expect to finish them before 2030, maybe. And for the detailed project, this is a lot of project put together, so maybe it is not a detailed project.
Okay. Another question from João Dias. So building these energy large space systems on remote areas and transmit it with HVDC is already economic viable?
Yes, we have calculated that if the capacity is more than 10 gigawatt or maybe 15 gigawatt, and the capacity factor is on the line, maybe on more than 4,500 hours, and the economic is available.
Is there? Okay, perfect. Maybe a final question to Johnny from Julia Pereira. Can you further explain or detail how the PV structure can decrease the impact of 10 plus meters waves? What are the main characteristics to dissipate the energy from big waves so that it doesn't destroy the PV panels?
Yes, thanks. So this is indeed a major challenge for offshore solar. And our concept of our technology, it has been inspired basically on nature. So what we see is like that very large surfaces, such as water lilies, are very good at harnessing in a very material efficient way solar energy. And that is also what we inspired our system upon. So what we do is, instead of trying to have the impacts from the waves facing our system, we try our system to let it move in such a flexible way that it actually follows the waves, instead of like that the kinetic energy of the waves actually impacts the platforms itself. By doing that, we can resolve most of the impacts. Then in addition, we also have a rigid structure of which our platforms consist of, that can handle the other aspects of the environment. So we design for both rigidity as well as flexibility, and that combination, that is our means of dealing with the environmental loads.
Okay, thank you, Johnny. I guess our time is over. I mean, there were many more questions, but now I think our time is limited. So I think we have reached the end of today's session. I really want to thank our guest speakers for the amazing presentation, and also for these clarifications in the Q&A session. And also to thank everyone that attended today's session. I don't know, Maggie or Ines, if you want to add something, but if not, I just want to...
Yeah, I just want to thank the speakers for the session and all the questions. I think this was one of the most engaging sessions we had so far, and we are really happy about it. We will have the next session in July, and you are all invited to see the session again. And so thank you a lot, and a great day for everyone.
See you. Thank you. Bye-bye.
Enjoy. Thank you.
Thank you all.
Bye-bye.